Algebra 2 2.4 notes over modeling with quadratic functions. So when you need to write a quadratic equation, we have kind of two options here. If you are given a point and the vertex, so if you know it's the vertex, and then one other point that's not the vertex, then you should use vertex form, which is, we learned it back in 2.1, it's y equals a times x minus h squared plus k. Now, or if you are given a point and also given the x-intercepts, which remember are p and q, then you should use intercept form, which we learned in section 2.2, and it's y equals a times x minus p times x minus q. And p and q are the intercepts. So on that one, you need the two x-intercepts plus another point. That is not one of the two x-intercepts. Okay, so this says the graph shows the parabolic path of a performer who is shot out of a cannon. So y is the height in feet, x is the horizontal distance they have traveled, also in feet. So right here, they give us a point, and then they give us the vertex. All right, and so it says, what is the height of the net where they land? So to find this, we need to first write the equation. So we have the vertex, which is 50, 35, and that is hk. And we have the other point, which is 0, 15, and that is the point xy. So hk is the vertex, xy is the other point. So we're going to take our vertex equation because we were given a vertex and a point. So I'm just going to write that down right here. Okay, so I'm going to fill in what I know. I know y is 15 equals, I don't know a, x is 0 minus h is 50 squared plus 35. Now, be careful in your calculator. Don't type all of this in, okay? Don't type all that into your calculator. The reason why is this section right here, this 0 minus 50 squared, it is attached to the a, so you have to type that in first. So when you type in 0 minus 50 in parentheses squared, you get 2,500, and that's times a, then plus 35. Okay, so from there, you're going to subtract the 35 from both sides, so you get negative 20. And then divide by 2,500. All right, and so I'm just going to kind of ran out of room. So when you divide by 2,500, you take negative 20, divide by 2,500. And you do that in your calculator, you get negative 0.008. All right, so your equation is y equals, your a is negative 0.008. In parentheses, you do x minus, your h is 50, squared, plus your k. So this is your equation. Now, if you want to know how high the net is, it's 90 feet from the cannon. So that tells you x equals 90. So you're going to plug x equals 90 in to your equation right there, and you're going to type that in your calculator. So when you plug x equals 90 in, you type that whole thing in your calculator, and you get 22.2 feet. So that's how high it is. Now, how I knew it was x that was 90 is because this point clearly has an x value that's 90 because you're 90 feet away from the cannon, and you're looking at the y value, meaning how high the net is off the ground. Okay, on this problem, a meteorologist creates a parabola to predict the temperature tomorrow. Okay, x is the number of hours after midnight, and y is the temperature in degrees Celsius. So if you see here, we have the x-intercepts, so they are p and q. So p is 4, q is 24, and the other point that they give you that's not the x-intercepts is x and y. So since they have the x-intercepts, the equation we want to use is we want to do the intercept form, which is this formula. Okay, so we're going to plug everything in. So y is 9.6. We don't know a. X is 0 minus p is 4. X is 0 minus q is 24. All right, so we get 9.6. I can go ahead and I can do all of this in my calculator or in my head because all of that is multiplying. So it'll make a -4 times -24, which is 96a. And then to get a by itself, we're going to divide by 96. All right, and that gets us that a equals 0.1. So your equation is a is 0.1, x minus p is 4, and then x minus q is 24. That's the equation that fits this parabola. Now, if we want to know the lowest, coldest temperature, that's the minimum. That means we want the vertex. So we're going to find the vertex. So remember the vertex, you take p plus q divided by 2. So that's 28 divided by 2, you get 14. And then you plug 14 back into your equation. When we talk about plugging it in, we mean put it in here and put it in here, and then type that in your calculator. And I get -10. So 14 hours after midnight, which would be at 2 p.m., the coldest temperature is -10 degrees. That would be Celsius. Okay. Now it says, what is the average rate of change? All right. Whenever they talk about average rate of change, they mean the slope. Slope is average rate of change. So it says, what is the average rate of change when it is decreasing and what is it increasing? And compare them. So decreasing is happening where it is decreasing. That happens here from 0.6 until the vertex. So it is decreasing from 9.6 to the vertex, which was 14, -10. So find the slope for that. Remember that the slope is y2 minus y1 over x2 minus x1. So that gets me, if I put that in my calculator, -1.4. Now, it is increasing on the right side of the vertex. So where it is increasing is right here. And it increases from the vertex, which is 14, -10, to the point where it stops, which is 24, 0. So let's find that slope. So we do 0 minus -10, 24 minus 14, and that is 1. Okay, so what this means, it also wants us to compare them. So the temperature dropped an average of 1.4 degrees Celsius. That is dropped because it's negative and it's average rate of change. So it doesn't mean exactly that, but an average of 1.4 degrees Celsius per hour. And that was from midnight because 0 is at midnight. And then 14 hours after midnight was 2 p.m. All right, and it rose because it's a positive slope, 1 degree Celsius per hour from the vertex, which is 2 p.m., until 24 hours after midnight, which is midnight of the next day. So to midnight of the following day. All right, let's look at example 3. Okay, this table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Okay, we are going to, when we have a model like this, we are going to use our calculator, and it's kind of similar to what we did back in chapter 1. First, we're going to go to stat. We're going to enter on where it says 1 edit. And we're going to put our x values in L1 and our y values in L2. So I'm going to pause the video and pull up my calculator and type my x values in L1 and my y values in L2. Okay, so where I went is I hit stat, and then I hit enter on edit, and that's where I typed in my data. L1 is the x values, L2 is the y values. Okay, now you're going to go stat, go over to calc, and then you want this fifth one that says quadratic regression. So go down to 5 and hit enter, or press 5. And then just go down to calculate and hit enter, And here is your equation. So this is your A value. We're going to call it negative 0.14. B, we're going to call 1.37. And C, negative 7.1. And you can see right here the format. Okay. So just to jot that down super quick so you have the buttons for that. Once we got the data entered in, we pressed Stat. We went over to the right to where it said Calc. And then we went down to the fifth one that was quadratic regression because we're making a quadratic equation. Sorry, it probably doesn't have it spelled out. So it's quadratic and then regression. All right, and we got y equals, our A was negative 0.014 x squared. Our B was plus 1.37 x, and then our C was minus 7.1. So it wants to know the optimal driving speed. You're maximizing your miles per gallon is what you're doing. So when it wants something like the optimal of something or the best case, you're going to look at the vertex. So if we want to find the vertex, we're going to do negative b over 2a. So that's negative, b is 1.37 over 2 times negative 0.14. I'm going to type that in my calculator, and I get, let's see here, 49 about. And then I plug that 49, that's the x value, I plug it back into this equation for x, both places, and I get 26.4. So that means when I'm going 49 miles per hour, all right, I get the best mile per gallon is 26.4 miles per gallon. So whatever this car is, it has the best miles per gallon rate when you are driving 49 miles an hour.